everyone. Monday night, and it is the Physicist and Philosopher. I am the philosopher, R. Wayne Steiger, and the physicist is Dr. Claudia Albers. How are you?
I'm fine, thank you, Wayne. And how are you?
Doing well, doing well. I have to say, it's been just another interesting week. And you know, Claudia, we're almost to the end of the year.
I know. I mean, I've seen some Christmas decorations.
Yeah.
And I think it's very strange. I had no idea so much time had passed this year.
Wow. You know, you actually wrote an article on that. We're going to review that. I just want to say hello to all of the folks in the chat room and those viewing. The March on America group, is that right?
Yes, the MFA, and they will be viewing this. Scott was supposed to be on tonight, but he's been up since 2 in the morning working on the different websites and YouTube channels, so he was just too tired.
Well, rest for the body.
Yeah, but he's got this lovely footage on these UFOs. It's amazing. They move so fast. They're tiny and they move incredibly fast.
Well, we'll have to get him on next week.
Yeah, I think so.
Well, the two of you are like machines. I just want to say hello to all the moderators. Thank you, folks. In fact, that's what I told Dr. Roberts before we go. Like, you're a machine. You just you get the stuff. You're just writing out, and it's
it's like I've got to get it out of me somehow. I have all these ideas. I work things out, and then I have to write it up. And I actually have a backlog of things I want to write about. They're just waiting in line to be written, you see.
What I'm doing, and I know that's kind of rude, but you see this? These are my ideas.
Oh, okay.
And there's another pile like it, but you know what? That's what's happening, Claudia. It's just, it's like knowledge is becoming so, I don't know, it's unfolding everywhere.
Yeah, I'm actually, I thought actually, I figured out this, how gravity works, why the sun has lost its ability to emit light and so on. And today I figured out all kinds of new things, like the sun hasn't died. It hasn't lost its energy. What it has is lost its atmosphere, its corona.
That's interesting. Now, there's evidence of that. Can I, Jeff P., I just want to give him a shout out. Did you see his video that he put out today?
I haven't yet. I'll look at it, but I haven't.
Well, I'm going to show everyone. So Jeff P., I'm giving you a shout out on this, folks. Go over there and check Jeff P. out. He's done some remarkable work. So Claudia, I wanted to kick off our show tonight by bringing in what Jeff P. has shown here. So this is kind of interesting, because when you see this, he actually captured the sun going dark. And to bring everyone into context on here, let me put his audio on. Let me tell you if you can hear this. Can you hear that?
No. Yeah, you see, that's the sun simulator.
Yeah.
And he actually saw it going dark. It sometimes fails, like I've been writing about. So that's amazing that he caught. Oh, wow.
See, this is remarkable, folks.
Wow. It suddenly just went out. Wow.
And he shows the exact same time of day. Jeff P., way to go, on the 13th, and then the exact same time of day coming in.
That's unbelievable. I mean, I'm going to look at this and use it in an article, I think.
Yeah, it's
great.
It is just phenomenal footage. And again, you see, I think that, Claudia, most people don't look up. They don't look up at all. And, you know, here is solid proof. I mean, there's the camera. You know?
I mean, how else? I mean, it can't be the real sun at all when it just turns off.
Yeah.
And like I said before, the real sun doesn't just suddenly turn off. When it goes dark, naturally, it's because of an eclipse, and it's gradual, and it never goes completely dark. And during in the SDO images, it also goes dark incrementally. It doesn't suddenly go dark. So it takes an artificial light source to suddenly switch off.
Well, and it gives Jeff P. Big shout out, my friend. Big fan of yours.
Wonderful work.
Yeah, I'll tell you, he is.
He always does wonderful work. Yeah,
I think it was
many years, and I've used a lot of his captures. I use it as evidence because they're so good, and I'm definitely going to use this one. That's wonderful.
Yeah, I mean, it's like you see it, and I actually have other stories that people have sent in. They're seeing the same thing. They're seeing anomalies in, let's say, when the sun should be there when it's not. So I'm going, hey, what's going on? So Claudia, I did also want to pull up some stories that I thought you and I might comment on before we get into some fabulous papers that you wrote. And these all dovetail right into the papers that you wrote this week. This is one I just wanted to see. So chip implantation is here. In fact, this article gets into more and more how in the next 20 years, all children are going to be chipped. That's scary.
Yeah, I think it may be closer than that. I think in just a few months, they may want to start implanting everybody.
Well, and here's the thing that they're doing here. Now, I come from the payment industry. That's part of my background professionally. And how they're getting people to bite on this, Dr. Albers, is that you will no longer have to carry a wallet with you. You will no longer have to carry any money with you.
Mm-hmm. Yes, but what happens when they just switch off your chip and then you don't have access to.
You see, now, isn't that interesting?
You lose your life, basically.
Yes, and think about this. Think about the new group of hackers coming.
Yeah, right.
I mean, seriously, these are going to be biohackers that will actually hack people's lives, Claudia.
Exactly.
I mean, this is scary stuff.
It's scary. It's scary. It's not wise doing something like this at all.
Well, you want to talk about a one world system? This is the precursor of what I see.
Yeah, I believe this is the mark of the beast. Or
I would agree with you.
This is evil. This is evil. This is trying to control a human being completely through this.
And I'm glad you brought that up, Claudia, because here's what I see technology has done. It's imprisoned us.
Yeah.
Before technology, let's say when we were an agrarian society, in a culture, you had your privacy.
Yeah.
I mean, no one probably even knew who you were unless your local group. Today, you and I, we're known worldwide. And this is, to me, now I won't get plant. To me, it's just, and maybe that's because, they know us hippies. We're just not going to do it. But this bothers me. I have a granddaughter, my wife and I do, and I think about what little Lydia is going to be facing.
How old is she now?
Let's see. I think she's coming up on 6 months old.
She's tiny.
Yes. Yeah. And I'll show you some pictures of her.
Okay.
Okay. Yeah. But yeah. So, all right. Here's another one. Here is in Asia. They're finding the most interesting things happening. Claudia, there are islands disappearing.
Oh my goodness.
And it's not just one. It's not just in Japan. This is the one I just found out. But they're finding islands appearing in the Arabian Sea.
Oh my goodness.
We're finding anomalies off of the coast of Brazil, which tells me that something's going on with our planet.
Something's definitely going on, and that's to be expected. I think I've written a little bit about this.
You have.
Fissuring is likely to increase because as these objects interact with the Earth, they have a gravitational wave pattern that goes over the land, and it causes the land to expand and contract. So when that happens, things are going to move.
Mm-hmm.
And so hills are going to fall down. Part of the ground may go up, part of the ground may go down.
I have a picture, Claudia, of the Mexican tectonic plate. The last earthquake that they had, that 8 point or 7, whatever it was, cracked the plate.
Oh my.
There's pictures of it now. It cracked the tectonic plate.
Yeah.
That's a lot of energy.
It is. And you know, it's only going to get worse. That's the thing. It's slowly, it's going to get worse. More and more of these objects are appearing. They have more energy, and the gravitational interaction will get stronger. So the effects are going to increase.
So this article is probably, when I read it, it really took me aback. You see, Claudia, I think they're making soft disclosure ahead of us. So now we have a star system they acknowledge came through our solar system 70,000 years ago, Claudia. Man was here. I mean,
well, I'm not sure about that, but
well, I know you and I have a different view on that, but the fact is that it's interesting now that you see astrophysicists, astronomers now coming out with the acknowledgement that here was a wandering star. That is what Nibiru means, wandering rogue star. And here is the acknowledgement now coming out of mainline science.
Yeah. Yeah, well, it's true that what we have is lots of stars that have entered the solar system. They're energy depleted stars, but they're still stars, parts of star systems.
Yeah.
So you're right. It is, in a way, disclosure.
Yes. Well, what got me is at the end of this article, and this is what said to me, now we know that we're getting correlation on these dates. I think we're getting closer and closer. Now, the article there saying that the Neanderthals were here, but we will move on to what I think is probably more important, is the fact there's another one coming.
Yeah, well,
and they actually say it.
The thing is, we have more and more of these objects coming in. They've been coming in for at least 5,000 years, like I said. And they call them comets, but these are not comets. These are the remains of stars. Some of them are smaller. They are remains of planets or moons. But the larger ones are remains of stars. That's why I call them stellar cores. It's what's left. So they are stars. They're coming in. And there could be some that have more energy than others.
I would agree with that. And you know what tells me, Hadi, when I think about this? So now they're telling us that all of us who were the Planet Xers and, the Nibiru watchers, that, 3 years ago, mainline science was mocking us. Yeah. They were ridiculing us. NASA was absolutely, it was just everywhere. It was a very dark time. I mean, as you well know. And now here we are 3 years later. And guess what? They're telling us that, well, yeah, there's rogue stars now.
Yeah, because they're not able to sway public opinion anymore away from the fact that people have started accepting that things are happening to our solar system. And also, I think they've decided to disclose the truth because they have realized they will not be able to hide it forever.
Yes, ma'am. I would absolutely agree. And that's what got me on this article, which tells me, Claudia, as you said last week, what they know and what they're not telling is a chasm.
Yes.
I really do believe that.
Yeah, of course. I mean, these people have all studied all the data that I have studied.
Yes.
So they've come up with all the explanations before I did, but they kept it to themselves.
They did.
Well, you know, I don't know if they came up with everything I did. They probably came up with a lot more because as I examined the data, and don't forget, it's me on my own. When a group of physicists studies data together, they will discuss it and, you know, come up with some better explanation than just one. It's just me on my own here.
Yeah. Well, I do know you have a following, so.
Yes, I know, but in terms of deducing the physics,
yeah,
I would do it better if I had another physicist to discuss it with.
I believe that one is forthcoming, Dr. Albers. I really do. Firmly am convinced of that. So we're going to discuss this because you wrote a paper on this and we're going to get on this.
Okay.
I actually had two other people who are avid supporters of both yourself and mine and sent me pictures of this as well. So this was in the UK.
Look at that.
Yeah.
That is a classic example of luminescent clouds in the sky. And this is due to stellar core dust entering our atmosphere. And as you can see, this happening more and more means that more and more of the stellar core matter is entering our atmosphere.
Look at that. I mean, that's just...
and what's actually happening is actually an exchange because we are absorbing the matter that these objects have or they've shared, and they're absorbing our atmosphere. We're losing our atmosphere.
I think there's good evidence for it.
That's the problem. But that's a big problem. If anything is going to end life on the surface of this planet, it's the loss of our atmosphere.
I believe you were right. Excuse me. So here is something that I thought was really interesting. This interstellar object that went through what now almost a year and a half ago.
Yes.
Okay, Claudia.
I wrote an article about it and I said it's a starship of, I said it's...
well, that is exactly what they are.
Maybe they're reading my papers, Wayne.
Maybe they are, because I found this. This is not only revolutionary in the fact that they're even coming out and discussing this into mainline the masses, the public, but is that it never goes away. And now we're finding out they're saying, and this is what I'm deducing, this is in fact of an alien source.
Well,
a solar cell.
Well, I'm not sure about that, but I think the fact that it slowed down, it speeded up and slowed down, something like that. And I immediately thought that means this thing is artificial. It's got some kind of drive system. So it could be, it most likely, if it came in, it will probably be trapped in the solar system.
You know, and this is just my mind pontificating that, all right, if there is a civilization, in which I do believe exists, that has the capacity to begin to do interstellar travel, that now we're saying that this has evidence that it is under control of something. So, question, Dr. Albers, would you pontificate if this was either artificial life being basically as a probe, or could there have been actual biological life on this as well?
That's a difficult question, but it seems too large for a probe. So it's most likely, it could be that the beings that were on it died.
So it's 40 meters long, wide, excuse me.
Yeah.
400 meters long.
Yeah, it's very large.
Yeah.
It's very, very large. A probe is usually much smaller, I would say. You don't need a probe to be that large. So it's probably a starship of some kind. It may have lost its drive system, and then it may have come in as if in free fall, but then it sort of decelerated and accelerated. It's something strange.
It did. It also made a very peculiar turn.
Yeah.
So, like, all right. So
that indicates that
who the hell's driving that thing?
It's under artificial control. It could be that there's no one alive on it and it's driven by some kind of computer system. But
I don't know.
I think it's artificial.
I would agree with you.
Yeah.
So I just wanted to get your take on that because we know something is afoot. There really is.
Yes.
Now, I have a little piece. Wasn't there a similar starship found on the moon by the Apollo missions? Yes, there was. Exactly the same size. But so you remember Fukushima?
Mm-hmm. Oh, I've written an article about it. Yes.
Have you and have you seen the Nigen?
The what? Sorry.
The Nigen.
No.
Okay. I think you're going to love this, Claudia. I think you really are. I got something I want to pull up, and I actually have the video of this, but I wanted to show you the stills. And this is why I know that there is life that may be even monitoring the life here. So this is the aftermath of the earthquake. This is the tsunami.
The tsunami, yes.
Yeah, this is 5 miles inland. And I have video from when this was drained.
So this is next to the river. The river.
Yes.
Yeah.
Watch the creature here, and I'll just start advancing it for you, as he says. Do you see him?
Oh my goodness, what is that?
It's a Nigen.
A Nigen? What's a Nigen?
And here you go again. I'll do some close-ups of these. There are an intelligent group of creatures. They're here again. Watch. See how he disappeared? Did you catch that?
He disappeared?
It disappeared. It actually has the ability. Now watch this. There's another one. This is 30 miles down the coast. It apparently, this earthquake destroyed their kingdom is what. Now here it comes right here. Watch. You see him? See him?
Yeah, I see something moving there.
Yeah, that's him. That's it. It crosses over. It's running for its life. It knows what's coming.
Very strange.
So let's go back and see. And yeah, I'm just doing this reverse, and now you can see how he's coming back. I mean, there it is.
Now, how do people know about these creatures?
Well, it is a legend in Japan that the Nigen are a very highly advanced species. It is
they live in the water?
Yes, they do. So now let's reverse this, Claudia, and I'll show you our little creature here. Watch, they have the most unique ability to camouflage themselves right here.
Mm-hmm.
There he is. Mm-hmm. And let's get close. There's our creature.
My goodness.
There they are. Now, let me show you his they obviously traveled in pods, and you can see now he's getting out of the water. Let's take a view of our creature here. And I'll get it when he's coming out of the water. Okay, so let me advance it one frame for you. And now let's take a peek at him.
Wow. Do they ever attack humans?
No, they obviously have the ability to, much like a chameleon, but they have the ability to literally take light. Here it's crawling out of the waters, looking for refuge. And let me go to the next frame. And now, so
you like shapeshifters.
Yes, thank you. Hold on a second here. We got robocalls coming in there. I've already voted. So here we go. Here's our creature.
They shapeshifters.
They're very large.
I
estimate them to be about 6 to 8 feet.
Well, they sounds like they alien.
Well, they live in the water. We know that. And let me get him as he crawls up. Here we go. You're going to really love this one, Claudia, as you see him as they crawl out. And there he is. Very large creatures.
Very strange. I'd never heard of these. But I'm not surprised. You know, when you hear about shapeshifters in movies,
and there you see them.
You know that they probably exist. They tell us the truth in movies and lies on the news.
You can see how he's moving. Now, I have the raw footage when this was shot, and we counted a total of 7 of them.
Wow, really?
Yeah. They were. It looks like that. What you don't see is right here is that there's.
Do they use technology?
You know, I don't know. You see what happens? You can see as he's crawling up, he's adapting to the environment and literally beginning to adapt to where he blends in. The one that I thought was really strange, and I don't have the footage of the stills on this one, but in another camera in another village down the road, they caught 3 of them literally scaling the buildings to get out of the water.
Wow.
Which tells me that in there, let's go another still. I thought you would find this fascinating, Clark.
Yeah, that's very interesting.
Now you can see.
I've never heard of anything like this. It's amazing.
It is, isn't it? And look how you can see the mass of the size. This is a building.
Yeah, they are huge.
And so one more, and as he begins,
so they can live in water and out of water. So they're amphibious.
Yes, and here, as you can see now, how he has completely morphed into the background.
Yes.
Fascinating, isn't it? I thought you might like to see that.
Yeah, that's very interesting. I mean, yeah. So do they have gills? You don't know, huh?
I don't know. And then here, I just want to show all the audience. I'm showing, give me one second, folks. As he says, where's my control? There we go. Cancel. I don't want to delete that. I have to go back and recapture. Yeah. And now look at this. That creature's here, but we can't see it.
Yeah, you can see some kind of form, but it's the same color as the roof now.
Yeah.
So they are chameleons. They can. Well, that's what shapeshifters do, you know.
So there is, again, and for the audience, so you folks know that, and tomorrow I'll actually, can actually show look at that.
Oh, there's one there. Yeah, definitely.
Odd, isn't it?
It's very odd.
So
there's so many things on this planet that are new, or
it's just
never heard of this before.
Yeah. So, it tells me, hello, Karen. I'm just seeing so many people in here tonight, Claudia. It's just, So when I see something like this, my mind begins to say, okay, there's obviously more than one life form and one species that I would say is higher on the food chain and even on intelligence than what we're aware of.
Mm.
And it's only through a disaster like Fukushima that as I've studied this and I continue to look into it, we know that their kingdom, whatever it was down there, completely collapsed. And yeah.
Unbelievable. I mean, there are creatures around the world that people are not sure what they are. What is it? Bigfoot and
Mm-hmm. Yeah. We I think that the Sasquatch and Yeti, I think they do exist.
Yeah.
I really do. So I have some
and
of your
the Loch Ness monster.
I believe that Nessie is out there. I'm convinced that, you know, when you look at the oarfish, which they say that oarfish, which can be up to some 20, 25 feet long, that it seems like they will come up from the depths of the ocean when there's the earthquake, a big earthquake going to come. They see that quite often. So I found your papers this week, Claudia, to be just, this is a good paper here. I love this one.
Oh, yes, the controlled scientific environment used to hide Planet X and its effects.
Yes.
Yeah, I enjoyed writing this.
This is a good article.
I think it was an article that I should have written some time ago, because it's something I know about very, very well. So yeah, I started out by saying that it's a controlled environment, but a lot of physicists don't know that it's controlled. They just think, okay, this is quality control. And this is where I was as a student, as a physics student, and as a young lecturer. I mean, I'd learned from my supervisor that you had to do certain things to get your work published. You always have to base it on previous work. You always have to make sure that you write your concluding remarks in a certain way. And I didn't see that as control. You know, I saw it as quality control. In other words, you must make sure that all research is of good quality. It's only later that I realized it's actually control over what is actually published. And your comments and the way you phrase everything is aimed at the reviewers you expect to get.
Interesting point.
Yeah. So, you know, but so the control is over physicists is basically through money. They're not really aware of it. It's about getting grants to do research. And there's always more money in certain fields than others. And the fields that have been getting the most money for years now is nanotechnology and lasers, photonics. Photonics labs are actually right at the top of the amount of money they're getting. And there's no real controversy or anything. Basically, it's all technology. You want to develop new technologies. You want to improve the power gains of lasers and things like that.
I made a ton of money, Claudia, in 2000 from companies like JDUS Uniphase, Redback Networks. They were the pioneers in delivering the light network for cable, not cable, yes, but optics.
Fiber optics.
Fiber optics. And odd that you're saying this, and I'll conclude with this, is that they just announced a breakthrough where they're going to be able to amplify the data packets into now more compression. They're talking 1,000 times faster than what we have right today.
Wow.
So you're spot on.
Yeah. So, but basically what I realized is laser technology, because I've done so much work on the sky simulation system, is exactly what they need. They need constant innovation in that for the technology they need from the sky simulation system. And all this started many years ago. And I even wrote an article that they can, through lasers, produce a way to have nuclear fusion, a nuclear fusion reactor powered by lasers.
Yeah.
And this was discovered in 1971-72.
So Claudia, speaking of lasers, so I have a set of military tactical lasers, and you know, I'm a consumer, I'm an individual, and now I can actually obtain lasers that will go 20 miles. I mean, that's incredible, isn't it? I mean, when you can start compressing it down to literally carrying it to something like this.
I know, it's amazing. And and that's nothing compared with what they can do with lasers. The power yeah. that they can produce in lasers is absolutely astounding. It's 10 to the 20 watts. That's 1 followed by 20 zeros, basically.
Yeah, you're getting up there beyond petabytes and theta.
Yeah, it's huge. Okay, it's a highly focused beam, and in the sky simulation system they have to spread it out, but still 10 to the 20 is just huge, absolutely huge kind of power that these lasers can have. And it's all because of a feedback system. In other words, it's recirculated.
Yeah.
The energy is recirculated, and each time it gains. There's a gain each time. It goes through the electric potential. And it's called stimulated light. So,
by the way, have you ever used a laser through crystals? I've been doing some photography on it. It's quite fascinating.
No, I haven't, but I've heard that crystals can also increase the gains.
Can you see that? So
what kind of crystal is that?
This is Karen. This is quartz crystal, I believe.
Okay.
She has, and can you see that? It has some remarkable photographic.
Yeah, it's beautiful, green and.
Yeah. So anyway, saw that it's quite fascinating. So I digress. Student, sit down. Let the teacher talk.
So there's been a huge increase in both these areas, but I think photonics is even more of a gain in photonics, because I've seen what happened at Wits University whilst I was there. The new researchers that were coming in and the grants they were getting, money to do research, most, if they were in these areas, nanotechnology or photonics. And just before I left, physics got more labs in photonics, a new researcher, a new chair in laser and photonics. So there was a lot of development in this area. So
who was primarily these grants coming from? Were they? I know corporations do a lot of spending on that. Were these government grants or?
What happens is it's a government organization that hands out the grants. And each year, the physicists, whoever's in charge of the group and individual physicists apply. So they have to write research proposals. And they spend a lot of time on these. And then the grants are given as a result of these proposals. And it also depends on how many articles they publish and this and that.
Okay.
But basically, this is how the control is yielded over these.
They pay your salaries too from these grants, right?
No, not salaries. The salaries are paid by the university. The research grants are for laboratory equipment, for travel expenses, sometimes to get to pay your postgraduate students, and travel expenses to conferences. And of course, if you're in experimental physics, and that's basically where the money goes, into the experimental physics groups that have laboratories, most of the money goes into the equipment. The equipment's very expensive.
And when you said experimental physics, I mean, that's kind of an area that allows, as I have been told with my colleagues out in Silicon Valley, is that you have some remarkable discoveries made in these much more broader fields. You know, when you say experimental physics, I mean, that encompasses a lot of different disciplines, even when the community of physics, doesn't it?
Yeah, because physics is divided into two main areas, theoretical and experimental. And even in each field, you have, so in photonics, you have theoretical physicists and you have experimental physicists, but I think most of them are in the experimental part in photonics. And perhaps they actually may be doing both, the physicists that are more involved in that, because there are some that are into quantum mechanics applications like tunneling and entanglement, and they use lasers to research what they want to do.
By the way, did you hear about Google's new chip? They've actually got NASA involved, and they're about to test this thing, and they're saying that this new quantum chip, Claudia, is going to open up anyway, it's going to be mind-blowing, so they say.
I'm sure it is, because most of these things are actually alien technology.
I agree with you. I think so, yeah.
Yeah, and that's where they got it from. Now, so the other thing I talk about is the control. Most of the control is over grants, and a lot of physicists are not actually aware. It is stressful to be a physicist because you continuously have to publish, and you have to be thinking on how you're going to get your research grant for the next year. So there's always this stress involved. I have to keep going forward in order to get my grant next year. I have to have more students. I have to get my students to finish their masters and their PhDs, and I have to get this research done, and I have to publish. So it's stressful.
It's a machine.
Yeah.
It's a freaking machine.
And then there's the other part of the control, which we learned about from Halton Arp, which is if you go into, you're doing your research and you find something that the powers that be don't want you to get into, then you start to realize how much it's controlled. Then your papers are not published. In astronomy, you write your applications for time on the telescopes, and it's always refused. So it's a project proposal, basically, that you have to write. And then if you need time at a large telescope, like Halton Arp needed, and then it's always refused. And your papers just are in the loop of review. They keep saying, oh, you need to change this. And you change it, you resubmit it, you wait a few months, and they say, oh, you need to change that.
Dying on the vine.
Yeah, so the reviewers never let your paper through. And then you try another journal, and they do the same thing until Halton Arp had to self-publish his own books. And because he basically falsified the Big Bang model. That's why I put this picture here. He's a controversy, which they call it. But basically, he showed pictures like this, where you have a low redshift spiral galaxy, that's NGC 4319. Its redshift is 0.006. It's very low, but it's connected by a luminous bridge to a quasar, Markarian 205, and its redshift is 0.70. Now, according to the Big Bang model, redshift is to do with recessional velocity. So a quasar with that higher redshift is moving away from Earth much faster than that spiral galaxy and is therefore much further away than the spiral galaxy. But then they could not be connected by a luminous bridge, because a luminous bridge means they're at the same distance from Earth. And that's the whole thing that Halton Arp said. That's how he falsified the Big Bang model. And this is not the only image, nor is it the only way that he showed that it was falsified. He's a very good astronomer. I know you have the book.
I do. Yeah, Redshift.
And he showed it in so many ways.
The math is a little above me, but
yeah. He's actually is not a, what do you call it? In physics, you would say he's an experimental. He's not a theoretician, let's put it that way. Okay. He's not a theoretical astronomer. But he's all about observations. He's not an astrophysicist. He's an astronomer. He's on to observations. So he actually had to get some help from a theoretician to come up with a theory that explains his observations. And that's in his book as well.
And I recommend that. We recommend that book.
Yeah, it's an excellent book. When I have time, I read that book again because there's so much in it. But anyway, so this is the other area of the control, is when you get into areas they don't want you to research, or if you start saying things that goes against accepted theory, then you start realizing that it's very controlled environment.
Well, this is just blatant censorship.
Yeah, it's of course it is censorship.
Yeah, I mean, go ahead. I'm sorry.
Sorry, I call it controlled because most physicists don't realize that it's censorship. To them, it's just stressful to keep up and keep going, and do what is acceptable to the reviewers and the grant givers and so on and so forth.
Now I know why all you folks are gray-headed by the time you're 40 years old. I mean, it's so true. You look at how many 10-year professors do you see that are always gray-headed? Is that is a hard thing to keep doing. I mean, it's like writing a new business plan.
Yeah.
All the time. I mean, that's wow.
Yeah, the thing is, and physicists work, and most physicists work until they die. They don't retire. The only retirement they get is from teaching. When they get to a certain age, they don't have to teach anymore, but they keep on doing research.
I mean, I have a lot of friends that are partners now in law firms, but all of them have the same story, is that when they were interning and going through the process, 110, 120 hours a week, and you physicists are on the same track. It seems like you're working all the time.
The thing is, if you start doing an interesting project, something that really interests you, and you're making progress and you're learning something new, and then you are sort of driven to do more. I think that's one of the reasons why physicists stay in the academic environment rather than going to industry where they would earn much more money. Because they can research what they think they can research. It turns out it's not quite like that. But if you're in photonics and lasers, there is no controversy. All you do is trying to improve on what's already being done. And you're not going to get into anything that the powers that be don't want you to get into. All it is about lasers and technology associated with lasers. So there you don't usually find problems.
No,
the same thing with nanotechnology.
Yeah.
You do get into bad areas in astronomy, in astrophysics, and particle physics. Because there you come across the Big Bang model, which is clearly wrong.
Well, now you're becoming a heretic.
Yeah, exactly.
Yeah.
Exactly.
That's
So,
how you're
and I
branded.
do mention here the NASA scientists, which are, most of them are most likely doing basically the same thing. They come up with mission proposals.
Yeah.
And the mission proposals are either accepted or not accepted. Either there's money then for their mission, and their mission may then become a part of another mission or so on. But basically, it's the same thing that they are doing. But they will be in a controlled environment as well. There's only certain things that you are allowed to do. And the missions that they come up with will, and that are accept, are most likely the ones that are useful to the powers that be, because they will be getting some data which they are interested in.
And by the way, for most people don't know about with NASA is that NASA's heavily subcontractors. The very core is because the subcontractors never know what the other subcontractor's working on.
Right.
Yeah, it's only NASA that gets the final data.
Exactly. And what was I going to say is, the other thing is, they don't really know sometimes what other groups are doing. They vary, but it's a controlled environment as well, because James McCanney was there when this data was coming in from the probes about the comets in the 1960s and 1970s, I think. And he could see that the data was showing something totally different from what was accepted. And the physicists used to actually sit and have meetings and try to figure out a way to make the statement, which was not quite what the data was saying, make the statement agree with accepted theory. He actually wrote that in his book, which I have right here. It's in his book, this book, Planet X, Comets, and Earth Changes. He wrote about that here.
Interesting. Now, Harrington was on the same track as well.
Yeah, and that's right. So he actually, his paper was published by NASA, his paper on Planet X, before he went to New Zealand. And but he must have found something they didn't want him to find. You know that.
He got dead.
They killed him.
That's all I can say. He got dead.
Yeah. I think we're fortunate that we're working on this, or I'm working on this, at a time when they've decided to disclose it, because they know they cannot hide it anymore.
Yeah.
Because if I had been working on this in the 1980s, they may have tried to kill me.
I think so. I mean, a lot of researchers in this field have turned up in, unfortunate circumstances. Their research stopped abruptly.
Yes.
Yes. It's like they got semen shoes.
You know, that's a very sad thing there as well. And again, it was about comets. He discovered that these comets impacting Jupiter. Well, and now I understand so much why, because these objects, these stellar cores, are comets.
It's interesting, you know, and I'm just waiting for the day when I see someone releasing a paper with a theory on stellar cores. I think eventually someone's going to try to steal it from you, Claudia.
Yeah, the thing is, they'll probably call them something else. And but, you know, I'm not doing this for the glory. I'm actually trying to understand what is going on. But no one else is going there. I think the powers that be are not going to allow. That's why I'm not in academics. I mean, the first thing they did was force me out of it.
Yeah. Well, it's better that when they brand you as a heretic, you know, as a rogue scientist, that, you know, your own brethren will take care of that by ostracizing you.
That's right. Basically, they don't want the scientific community to start working on this. They don't want it to become accepted in the scientific community. Where I'm doing it on YouTube, that's okay.
Yeah.
You know.
But what I keep saying, and I just, you know, You know, I read like you do, and constantly I'm seeing we're redefining our very ideas of how the universe itself was formed. I mean, we're now finding out that there are more planets than there are suns. We're finding out that the planets don't operate the way that we thought they do. And so, Claudia, what I'm trying to say here is that the reason why I enjoy having you as a friend and as a colleague is that you're approaching this in an area that has to become approached. Otherwise, we'll live in ignorance.
Yeah, I mean, I do the best that I can to come up with good deductions using whatever observations I have. Basically, it takes thinking, it takes putting things together, and try to make sense of it. But basically what I discovered is stars and planets are exactly the same thing. There's no actual main difference except maybe size. So a star like the sun that's 100 times larger than the Earth has a much larger core and is able to generate much more energy, and because of that it's able to emit light.
And isn't all stars out of stellar dust anyway?
Made out of stellar dust.
Yeah.
Yeah, I mean, they have the same type of core as planets, and cores form just like that. I mean, they don't form over millions of years. Cores of planets or planets. Planets are ejected from very large, and stars are ejected from either galactic nuclei or from larger stars. And they form from one moment to the next. Whenever there's that matter creation event and it comes from an object that has enough energy, as the sun produces solar wind, it creates matter to create that solar wind. A larger star will not just create a solar wind, it will create smaller stars and planets and eject them.
And that's exactly what we're seeing.
Yeah, and planets emit light as well. A planet Earth emits light from its atmosphere in the form of lightning. So there's every planet.
I was looking for the book I'm reading, Worlds Colliding, and it's very interesting what we're even discovering now, that how the planets, the inner planets, clearly show that something threw us back in towards the sun. And, you know, it tells me that we still don't even understand our own solar system.
Yeah, we don't, because what probably happened was the sun and most of the planets in the solar system were ejected out of the same star or the same globular cluster, were ejected out, and then they came together into one solar system. It's not that there was a cloud of dust that gravitationally collapsed and then the star formed and the planets formed. That's the accepted theory, but that's not how it seems to be. And you can even see it from the fact that the planets and the sun are inclined with respect to each other. I think the sun is inclined by 6 degrees with respect to the plane of the planets.
Yeah, I think you're right.
And that's because they were formed independently, and they came together into one solar system.
You know, that's the thing.
Yeah.
Claudia, it's the thing I never, I still get, in my mind trying to figure this thing out, is that, so gravity as a compelling force that forms, forms galaxies, it forms solar systems. But when I look at the vast plane of space, I'm asking myself, then how do these vortices begin to form independently of each other?
Yeah, the thing is, gravity does not do everything by itself. There always has to be an opposing force. So there's always two forces. So that's why in my theory, I always use gravity and the electrical interaction. They oppose each other. They're opposites to each other. But even gravity itself has an attractive and a repulsive part. And it's the repulsive part that causes a negative ions to be repelled by the core of a celestial object. And then it moves to the outer layers, and that creates an electric field in the outer layers. And it's this electric field that allows then that object to emit light.
Can ions have different atomic weights?
Yes, they do. So heavier ions have more protons. So hydrogen is the lightest atom. If it has one electron, it's a neutral atom. If it loses that electron, it's a positive ion. And then it will belong in the core of the object. Okay. If it gains one extra electron, it's a negative ion, but then it's one proton and two electrons in the outer shell.
And the atomic weights of each one of those would have obviously an impact on the formation of a star itself or even a planet, wouldn't it?
Yeah, but what seems to actually happen is the matter creation event creates basically protons and electrons. And then these come together and form heavier nuclei. So there's huge amounts of fusion that quickly occurs as the matter emerges.
Okay.
So the whole thing forms, and the denser part goes into the core. That's where the gravitational attraction will be strongest. The gravitational attraction is always strongest when you have heavier ions, more protons. It's the protons that generate the attractive part of the gravitational interaction. So that's why you always get protons at the center of atoms, and you always get more protons at the center of stars.
I'm going to pull up something, Claudia, because I just want to, when we're talking about this, we have some really good visuals to help explain this. The picture even behind me helps explain it to a degree. Let me pull this up so you can actually, as you were discussing that, so let me pull this up and share it with everybody. Because this was always the one that fascinated me, is when we actually began to see what was at this stellar core.
Yeah, I learned so much by analyzing this image. And this is the nucleus of our galaxy, basically. It's the center of our galaxy. But a galactic nucleus is actually very small. This thing is about 1,000 light years across. And the galactic nucleus is only about 100 AU. So it's a small, tiny little thing. But when I analyzed this, I realized that there were ejections coming from different areas. That's what those lines, those bright lines are. Those are ejections from the center of the galaxy. But they're not happening from just one spot. And then I realized that our galaxy is older than the new galaxies that have very compact galactic nuclei. So our galaxy's initial galactic nucleus has broken up. Why did it break up? Because as it gets older, that's the characteristic of structure and matter in our universe. It expands and breaks. It broke into pieces and it spread out. And then each piece is doing its own ejection. And the ejection is in the form, it's like liquid. It's in a liquid form what it ejects.
Wow.
And then it condenses into little particles. Each little particle becomes a star and it continues to expand. And that's how a galaxy populates its arms, the galactic arms. It's through ejecting these globules of liquid material, which then condenses into actually smaller particles. It breaks up. It's like huge stars start to fission into smaller stars and start to fission into stars and even smaller stars, which then become planets. So there's this breaking up and this fissioning, this spreading out of energy, light, and matter.
It's just, when you talk on this, I mean, this is just beyond my comprehension. I don't know what's going on here.
Yeah, but that's obviously the part of the galaxy that has the most energy. But even beyond that, we can see spots where these lines these are ejections. So these are parts of the initial galactic nucleus of this galaxy that has broken apart and it's spread out.
I'm just getting some of the filters.
Yeah, that is absolutely. And you see these sort of circular structures. These are parts of the ejections that are coming from the galactic nucleus. And you can see it on the right-hand side, these circular patterns. Yeah, everywhere there, smaller ones, and then further out on the left-hand side, we see these are globular clusters. Before they become globular clusters, at the moment, they're just huge globules of liquefied matter.
It just blows my mind. And Claudia, when I was analyzing these in the different filters, is this a rotation? I mean, this has to be just incredible speed.
Yeah, they eject at huge velocities because the electric potential in the outer layers of these objects. Remember what I said about the sun. The sun has matter creation events. That's why it has a solar wind. The solar wind is the product of the sun's matter creation. And it's a result of the acceleration that occurs due to the electric field in the outer layers. So that accelerates matter, but actually it's not just that. The electric field is so strong that the gamma rays, the gamma ray photons that are created in the core of the object move out through all the layers. When it reaches the outer layer, it goes through this very strong electric field and it splits the photon apart and matter comes out of it.
Wow.
And then this matter comes together almost immediately and it forms a spherical core.
It just,
not so much with the sun. Our sun is not as strong as some other stars. I think our sun, the main production that occurs there is basically stellar wind, which then goes into populating its nebula clouds or the planetary nebula that it has.
When I think of the mind that created this, blows me away, Claudia. It just, because it's just.
Yeah, but you see, what makes sense, it never made sense with accepted theory, is this happens over here and that. It gets very complex. They come out with different stories to explain different things. It never quite gels together. But now we have the same thing, the same structure in atoms, in stars, in planets, in galactic nuclei. Everywhere it's the same structure because it's the same laws, the same physics everywhere, at the small scale and at the large scale. It's the same. It starts to make sense out of the universe.
Claudia,
it all comes from light.
Yes, and that, if you read my mind, will you get out of my head? Is light escaping here? And this is what I'm trying to get my head wrapped around.
Okay, so what we're seeing there is actually matter that is extremely energetic because it's just been created. So it emits light. But the matter itself came out of light because the cores of objects, galactic nuclei have cores, generate high energy photons, extremely high energy photons, and generate an electric field, which is very high as well. When you combine the two, a very high energy photon and a very high energy electric field, you get matter creation. Matter comes out of that photon. But now we have matter that has a lot of energy as well. So it starts coming together. Fusion occurs, heavy nuclei start forming, and the cores start coming together. And cores immediately start generating energy again because they start ejecting more photons. So there's a lot of light. So light creates matter, and matter emits light. So it's a feedback loop all the time.
I can't help but think, Claudia, that the discoveries of new particles, new elements, I mean, who knows, maybe we might even find a new type of light.
I mean, there is no limit to the energy which a photon can have. We just call them all gamma rays once they get above a certain energy. But the heavy nuclei that can form, there's no limit to that either. So a galactic nucleus will most likely have much heavier nuclei in its core than a star's core. It may have, I mean, uranium has atomic number of 92. Technically, we could have an atomic number of 1,000, say.
Wow.
There's no limit. There's no limit. And the heavier the nuclei, the more energy will be generated when it fissions.
Yes.
So you get higher energy photons coming out of that core. And that's why galaxies emit so much energy.
It's just beyond me. I tell you, when I look at this, Claudia,
it's beautiful. The thing is, what I found out through studying the stellar cores, it's self-consistent theory. It makes sense. It holds together. It even agrees with the Bible, because the Bible says that God created the universe with light, out of light. And God said, let there be light.
He did. And as Sheldon Cooper said, God's a photon. Because it's light. But it's so true. But the reason why I always love those galactic core pictures as well is that because it so perfectly fits your hypothesis of, when we look at this matter, and most of us, and I admit it, when I see this, it's over my head. I'm in awe of it. That's why I got the poster made.
Yeah, it's an amazing picture. I'm so glad you sent me that picture, because I learned so much from it. And I must say, I'm amazed about it all myself. I find it totally amazing and beautiful. And I am so grateful that God has placed me in a position and has used me basically to find out how the universe really works, because we haven't been told the truth.
No, we haven't. And yeah, I just want to, as a philosopher, you just said something very profound. What we just all experienced, the 300 plus people that were there when we were showing that, you had the opportunity to see something that our ancestors they could even fathom. Claudia, they could not have even imagined that the core of the very galaxy itself.
Yeah. Yeah, the galactic core.
Well,
I'm always so happy to be able to explain it. And that every time I explain it, I understand it better. That's the best thing about teaching, is that the teacher learns the most.
Yes. Yeah. Says thank you for excellent education and weekly update regarding current events. Thank the professor. That's what she does. And I keep telling you folks, we are blessed to have, I think, one of the most brilliant minds of our time. And that's just my position.
Thank you.
Well, you're welcome.
Yeah, I mean, I cannot say I have learned everything. I am still learning, but what I've learned so far, and what I love the most, is that it makes absolute sense. When a theory is self-consistent, when you see it being applied everywhere you look on the small scale, do you know that quantum mechanics and Einstein's theory of gravitation are not self-consistent? They oppose each other. They will never come together. And that shows you there's something wrong with both theories.
Oh, that's beautiful, Claudia. I just saw that where you have quantum on this side, you got gravity on this side. So at what point does each cancel each other out?
The thing is, gravity only holds on the large scale, and quantum mechanics only holds on the small scale.
Ooh, so where do we have this barrier then?
Because whenever you incorporate gravity into quantum mechanics, it basically, the description fails. You can do it with string theory, but even with string theory, there are huge problems, and you can never come up with something that's verifiable, quantifiable and verifiable. So there are huge problems with putting the two theories together. Because you see, Einstein's theory is about space. It's about the geometry of space. And you cannot use the geometry of space in quantum mechanics.
Very, very well put. Yes. Yeah.
Yeah. So, but my theory doesn't. It holds true on all scales. The tiny scale, the microscopic scale, the atomic scale, and the galactic scale. It holds true at every scale.
I'm just loving this. This is like this is good brain candy. That's all I got to say. Oh, I mean,
that's the thing.
You know, we ought to do a show just on those two factors and how you tie them in together. I mean, because everywhere we see is quantum computing, quantum mechanics, you know, and then you have, you know, the whole thing with space, the universe, you know, how does the two? I mean, yeah, I get it. When I look at the universe, I get it. There's a quantum side to it. But, you know, I can't see the quantum side.
Yeah, you see, the huge problem with quantum mechanics is that it's all about probabilities.
Yeah.
You have a probability that something will happen. In other words, you cannot ask the question, why did that happen?
Correct. Oh,
because
very good point.
There's just a probability that it will happen. So you're not looking at the cause for something happening. Whilst I always ask the question, I see a stellar core doing that, why did that happen? And then I come up with an explanation of why that happens. And my theory now is self-consistent, where you can explain why we see certain things happening. Why can we see a stellar core so close to the sun and the solar system hasn't been disrupted? I can answer that question because gravity is dependent on energy, and that object is low in energy. So its gravitational effect is small.
Interesting. I just caught that. So gravity and the force of gravity would be equated to the energy of which that gravity is either associated or a part of.
Yes, and it's energy in the form of a gravitational photon. So it's light within a particle. Photons can exist as free photons moving at the speed of light and as energy inside a particle.
I can see that. Yeah, I can see that.
Yeah. So the stellar cores are low on photons within the particles.
That leads me, before we get out, I want to show you a picture one of our subscribers actually sent. So give me 1 second. I want to pull this up, Claudia, because I think this is, that's the one. So let me get this. I think you're going to like this. This was from Sweden today. One of our viewers. There you go.
Oh, yes. That's amazing. That looks like one of these lenses. It's, JFP also did some work on this. One of these lenses that they actually create out of the atmosphere.
Look at that.
It's amazing. Look at the interface there. You see, it's just atmosphere here. They create them out of atmosphere. And the way that I think they do it is they use sound wave generators to increase the density at a certain spot in the atmosphere, well, along that curvature there.
Yeah, isn't that odd?
Yeah, but if you take a video of it, it's actually oscillating because sound waves have to oscillate. So there'll be an oscillation right there, but it will be stationary at that point. It'll go up and down, up and down. Okay.
Isn't that odd though? That one just caught my eye. Yeah.
That's a great capture.
Yeah, I said, okay. I mean,
yeah.
I said, way to go, Sweden. I mean, they know their stuff.
Yeah, that's wonderful.
Well, Dr. Albers, we have definitely extended. People said they wanted a longer show. I think we've definitely given them that. So
yes.
This has been a fun evening again. Claudia, thank you.
Yeah, we've discussed, I think, some very important things about our universe. It's been a lot of fun.
Thank you. Everyone, thank you. We've had a full room in here the whole night. Just thank you to all the moderators. It looks like the room was well behaved, respectful, and exchanging good ideas and not shouting at one another. So thank you, moderators, and thank you, everyone watching.
That's wonderful.
Yeah, it is wonderful. It makes me feel good too as well. Shelfless Pug. This is the sweatshirts. If y'all want to see what they look like, this is the ones, Claudia.
Yeah, it's beautiful. I've been forgetting to get one, but I'm going to get one.
And folks, what I really like about these is that they're light and they are soft, Claudia. They feel good next to you. So your skin, it's good. So, well, Claudia, anything you'd like to talk about this week? You have anything or?
Yeah, I never know. I'm working on these new ideas that I've had, which explain why the sun actually has gone dark. And I've decided there's a difference between, I'm still working on it. Cool. There are two things going on in the sun, and it's the gravitational energy and the fact that it's generating energy. So that does two different things in the sun. So I'm writing about that right now.
That's great. And I did a little experiment of my own. I went back and looked at the ACE data, and anyone can do this. Go back 4 years ago and look at the wind speed, the solar wind speed coming off of our sun. 4 years ago, we were at the average maintained speed was 450 kilometers per second. And Claudia, today, the average is now down in the 280, 270 kilometers per second.
Yeah, to tell you the truth, I don't even know. If the sun's gone dark, I doubt that it is actually having any solar wind at all. Any solar wind that is actually hitting our planet is due to the stellar cores actually coming in. I don't think it's coming from the sun, because the sun is not able to emit light because it has no atmosphere. And the sun will create its own atmosphere because it can do matter creation events. But basically, the stellar cores are taking everything it's creating. So it's not able to generate a solar wind then. And I think the data that they're giving us at the moment is probably old data. I've discovered that the SDO images are at least 13 years older than the timestamps.
Boy, they've used that tactic before.
So not probably all the data is at least 13 years old. They probably put it all together. It's from a few years back, and that's what they're feeding us, trying to tell us, oh, the sun's still shining, still has a solar wind, everything's fine. I don't think so.
Well, we know in parts of the world it's blinking. Out.
It's blinking because they replaced it with a simulation.
Like, can you get the light bulb and get that going, please? Well, all right, everyone. We'll see you again next Monday night here. Be good to yourselves. Make sure to subscribe to Dr. Albers' channel, Planet X Physicist, and Scott says Planet X News. Is that correct?
Yes.
Yes,
And
yes.
yeah, Scott works very hard.
He does.
He just found this wonderful, you should go and watch his video on these UFOs to do with the simulation system. And they're moving so fast. I calculated the speed. It's about 40,000 miles per hour.
That's hauling.
These tiny little objects are moving at.
Wow. I see. I think that's what we're looking at today. It's not the same. Well, Claudia, be good to yourself. Get some rest. Everyone, thank you. We'll see you next week. Claudia, stay on here a second, and we will see all folks next week. Thank you for tuning in. We know you have different choices, and we do appreciate it, and it's a great honor to have your company. All right, folks, be good.
Thank you. Bye.